What this presentation is going to entail is how to set up a SCADA system in 20 to 30 minutes. First thing we're going to do is we're going to configure a simple HMI. We're going to configure points from a Bitronics SCADA panel meter. We're going to configure the Orion to read the points from the meter. We're also going to configure the Orion to pull points from Schweitzer relays. Once we've got all those points configured in the database, we'll then set up a slave port to the SCADA master station. So configuring the Bitronics 50 series SCADA meter, pretty simple. The 50 series uses a web browser, so all you need is an IP address of the meter, launch your web browser, make the connection, no software needed. All the configuration is done via HTML. The first thing we're going to do is we're going to go in, set up some unique settings for the device. We've got some options like feeder names if you want to, or a substation name. Not necessary to make the meter work, but comes in handy if you're doing configuration files, maintenance, etc. This is the setting screen that you pull up. The first thing you're going to do is define the meter's configuration. Am I 2, 2.5, or a 3 element meter? What's my CT and my PT ratio? What's my demand values? And all of these are done in increments of seconds. So 900 seconds would be 15 minutes, for example. If we're going to do any kind of harmonics, quantities that we want to bring back, set up our TDD denominator. This particular meter also has the ability to do loss calculations. So if you want to know your transformer loss, your line loss, we can program those into the meter as well. Most of these settings can be done also via the front panel. So if you forgot your Ethernet cable or your laptop dies, you don't have to worry. You just have to know the keypad strokes, and you can do all of this stuff that I just showed you right here on this screen via the keypad. The next thing we want to do is give this particular meter a unique IP address. We can also do that via the front panel as well. My next option is to select the protocol that I want to use. This particular family of meters has both Modbus and DMP available. I can select one or the other. I can't use both. Once I've selected my protocol option, in this case it's DMP, I have 2 additional options to choose: optimal resolution or primary units. Optimal resolution is your A to D counts. So 0 to 65,535 or minus 32,767 to plus 32,768. If I choose primary units, then that's basically what I'm going to be using. 1,000 amps, 10,000 volts, etc. Some master stations like to see primary units. Some like to deal with optimal resolution. Excuse me. Notice I have sessions to select from you when I use DMP. Actually, in this particular meter, I can support 3 simultaneous selections. Session number 1 could be serial. Session number 2 could be TCP to a unique master station, and session number 3 could also be TCP to a different master station. Those settings could also be done via the keypad on the front panel. The next thing I have to do is select the points list that I want to use in the meter to make available to SCADA. In this particular case, you'll see I've got a whole host of different quantities available, and all I'm going to do is go down the checklist and decide which points I want to respond to a Class 0 request, Class 1, Class 2, Class 3 request. Once I've done that, I'm going to select those values, map them over, and these are the quantities that I'll have available to the Orion or to a SCADA or an RTU. In this particular case, we'll just select all of them, which is the factory defaults. We refer to it as the Bitronics Legacy Fixed Point Register Set. I also have the ability to set up different time sync options. And depending upon which model you're using, we've got specific options available. On the M650 series, it's strictly DNP3 time, and I have to request time from the SCADA master. On the new PowerPlex 2, SNTP iRegB is also available. For the display, I can go through, I've got a checklist of the different quantities that I want that panel meter to display, either as I scroll through it manually, or if I put it in the auto scroll mode, those are the quantities that it's going to display for me. Out of the about 58 values that we've already defined for you, we also give you 10 user-defined values, so you can actually go in and write a custom display if any of those screens don't match what you want to see. And this is just a web browser interface. Once the meter's configured, you can bring up your web browser interface, use your relay test set, inject some voltages and currents, and see it real quickly on your web browser, Firefox, Google Chrome, etc. On the PowerPlex 2, that also has synchronizing quantities, we also give you a little sync scope that you can utilize, and you can actually look at the slip frequency, the different variations between the two bus voltage inputs. So the meter's configured, and now we're ready to go on and set up the three Schweitzer 751 relays that we want the Orion to pull data from. So the first thing we're going to do is open up our NCD software, NovaTech Configuration Director. It's a unlicensed copy. You can put as many copies of this software in your corporation wherever you want. We don't charge for it. It's an offline configuration tool, so you're going to do all of your configuration offline. You're then going to download it to the Orion, make that file active, and then you're going to start your testing. So the first thing we're going to do is open up a new file, and we're going to select which particular model we want to communicate with, which one we want to configure. What's unique about NCD is NCD works for all of our current Orion family. So you've got one software package that you have to work with, and we can configure all of these different Orion products. So we just continue to enhance, and as we add new products, we just add it to that piece of software. So when you open up your desktop, if you're dealing with an Orion product, all you have to look for is one icon on your desktop. We're going to select a standard NCD file. That means I'm configuring one Orion. I do have the option, if I go cascaded, that tells me I have a master Orion and multiple Orions connected to it. So if I need to add 16 additional serial ports or 32 more serial ports, I can add multiple cascaded Orions, create one NCD file, send it to the master Orion. It promulgates the data to all the associated attached Orions. So the first thing I'm going to do is go in, select my serial ports. Port number 1. I've got a whole host of protocols to choose from. In this particular application, since we're dealing with Schweitzer relays, we're going to use the Schweitzer fast messaging protocol. Once I've selected the protocol, I have to go in and select the relay hardware that I want to communicate with. What we give you is we've probably got well over 500 pick lists already predefined. So all of the Schweitzer relays, all of the different IEDs that we've supported over the years, we continue to add to that CSV folder of all of these predefined devices. If, in particular on Schweitzer relays, if we don't have a pick list for a particular relay, Schweitzer relay that you're working with, under the Files section, in that drop-down menu, you'll find a tool called Relay Helper. Relay Helper allows me to connect directly to the relay. Run Relay Helper, I do a quick FID DNA. I bring those points back. I do a quick comparison to my CSV file. If the file doesn't exist, we're going to create a brand new file for you right there in the substation. It stores it back into the defaults, so you don't have to call us and say, can you help us develop a new pick list? It does it for you automatically. Now that only works with Schweitzer ASCII or fast messaging, not as DNP pick list, not as Modbus, just fast messaging. Okay, I've selected my relay. I'm going to give port 1 a particular name that makes sense to me. Feeder 1, Schweitzer 751, breaker 123, etc. For the port, I'm also going to give it a specific name that makes sense to me as well. So this is where I'm going to go in and make sure all of the port parameters match the relay that you're working with. The next thing is I'm going to go through the default tag names. This is all that pick list. These are all those points that we've created for you. And so now all you have to do is select the quantities that you want, map them over, and then that becomes the SEL master port. Those are the points that the Orion's going to pull back from that relay on that port. Okay? Same way, excuse me, same way on the outputs. So I'm going to select whatever outputs I want to control, breaker control, any of my remote bits. Notice when I bring the points over, it assigns that particular unique name that I assigned to that particular device. Okay? So the Orion can send control commands through the relays, through the reclosers, through the I/O. The next thing I'm going to do is take port number 1, because I have 2 more identical 751s, I can simply use the copy and paste option. So with port number 1 open, click on copy port. I want it to go to port number 2. I send it to port number 2, and now I go in and rename and give that port a particular unique identifier that makes sense to me. I'm going to configure another relay identical to port 1 and 2 and put it on port 3. Same thing, copy port, put it on port 3, change the name, something that makes sense, and that quickly I've configured 3 IEDs from Schweitzer, all to communicate on ports 1 through 3. Now on the Bitronics, it's going to be a network connection. So instead of serial drop-down menu, I'm going to go to the configure network port. And from here, I'm going to select DMP3 master. Now when I select DMP3 master, the first thing I'm going to do is go in and set up a specific port name and the IP address that we programmed into that Bitronics M650 meter. Once that's done, click on Add New Device. The next page that comes up is you'll see we have a whole host of companies that we have DMP profiles for. So I go down the list, pick the company, and then all the different models that we have DMP points lists for. So in this case here, it's the M650 standard. Select that. Same thing, I'm going to go in, make sure I've got the proper device address for DMP, select my inputs, and here's the pick list available for that particular device in my defaults folder. Map those points over, and from here you'll see how my points are arranged. My analog point 0 through 8. You'll see my min-max, my scaling. I can change those individually. I can change those using common attributes. So those are the points that I'm going to put in my bucket of real-time database points in the OrionLX. And there's the port. So those are the IEDs that I'm going to be pulling data from. The next thing I want to do is set up my slave port. So all I'm going to do here is define a port. It could be any one of those 16 ports, or it could be port B. Port B on the back has the option to be a modem port. So if you've got a Bell 202 or an old 4-wire lease line modem that you want to connect, that's usually the port that people use, because that also supports all of the modem handshaking commands and what have you. But you can put it on any port. I'm going to go in and select my slave protocol. So the Orion is a master to the IEDs that it's connected to. It's a slave to the SCADA master that wants to pull data from it. So I'm going to pull up my DMP slave option, assign a unique port name, add an RTU. From here I want to give it a specific substation name, whatever the device address is that SCADA has told me to assign to it. Once I've done that, real simply just go down, click on the inputs. So now I have all of the data available here that I've configured from those 4 IEDs that I want to bring data back into. So you'll notice there's the SCL 751 on feeder 1, 2, 3. I can group these, sort them by descriptors, so I can do searches. There it is for the Bitronics. I also have points available that the Orion creates that I can also map to SCADA. So security points, login sessions, how many times people have tried to access the remote session, secure shell, any Ethernet activity. Okay, so these are some new security points that we've added recently. Not required by NERC-CIP, but it sure makes for handy application if you are concerned about if it's a particular NERC-CIP substation. So typical security points that you might want to map over to SCADA as well. So I grab the values, map them over, and now these are the values that are going to be presented to SCADA. So those are the points that SCADA is going to request and receive from the Orion on that SCADA port. Once again, I set some common defaults, but if I need to go in and change those, change scaling factors, change deadband, I can select all the points, do a common attributes, change it one place, and it changes all of it for me. I don't have to go in and change it individually. Okay. I'm going to save the file, give it a unique name. I'm going to download it to the Orion, make it active, and now I'm ready to start my testing. So I've got the Orion completely configured. We're going to start testing, making sure those values, we can force inputs, we can force outputs. We can actually take our relay test set, hook up volts and currents so we can see the values that are coming back. You can take your ASC test set now and you can start seeing what SCADA's got available. We also have a little built-in poor man's ASC test set that you can actually see DMP traffic. You can also see real-time information as well. So that's it. We're done with the configuration. We're all set to send that information to SCADA. And now we have the ability to create a local, simple, one-line screen using a little drawing tool we call Inkscape. So if you got a local HMI application inside the substation, or if you want to connect to it via a browser and view the data, we can do that. So how do we do that? First thing you want to do is get you a little drawing. How do you want your one line to look like? Do you want to import a PDF? Do you want to take a picture of something? Always best if you use NovaTech paper. Bring that, import that into Inkscape. The tool that we use to link the data that's in the database in the Orion, so the fast messaging protocol, the Modbus protocol, the CDC, the Conatel protocol, is XML. So we're going to create all of those points in the database that we're going to convert it to XML, because XML is our link to our Inkscape, our drawing package. So once again, here's all the data that's in the database. Select the points that I want to be able to use in my XML or in my Inkscape file, map those over. This is where my conversion takes place. Okay. Open up Inkscape, start a new file. You can open up, you can use grids if you want. It makes it easier to snap to grids. If you don't like using grids, you don't have to. Select your background color. We have some predefined images that you can use. We have some utilities that use a MapQuest map. What that allows them to do is select each one of the different substations, and then it takes them to, using a hyperlink, to a different SVG file that opens up the substation one line or some additional information. We also have in NCD a complete library of templates and switches, tags, hotline tags, text files, so you can scroll through and you don't have to worry about redrawing these tools. We've already provided them for you. Okay, so I've got my little Substation 1 line imported, and now all I'm going to do is use that HMI template that we provide, select the object that I want, overlay it, and now I can just start attaching lines to represent bus bar connections. I can click on rectangle, animate that rectangle as a control point. So I select the object. What we then provide is, under extensions, an HMI extension. So it's a little Python executable that allows us to now go in and animate that point with a object or a point in that XML database. So when I select that, this is what pops up. I'm going to go into my drop-down menu and pick out what point in that database I want that object to operate on. So when the input 1 on this particular device goes high, what's the color going to be? Is it going to be red? Is it going to be green? This is where I'm going to make my selection based upon that binary input, its state. The next thing I'm going to do is select the analog object, and I'm going to do the same thing. HMI extensions, pick a decimal value because it's now an analog. Where am I getting that analog value from in the XML database? In this particular case, it's coming from kilowatt readings from feeder 1 from the 751. Define how many decimal places I want that value to be, and I'm done. And now I can do copy and paste. So I could take that, copy it, create another. All I have to do then is go in and change the text so that each one's a unique, its own feeder. I can also animate switches. So if greater than 0.5, it's in this position, this little symbol is shown. If less than 0.5, this position is shown, and this goes away. So that's basically how we animate a switch, is just a value less than or greater than that particular point that's going to animate that particular object. Once I've created my one line, now all I have to do is remove my drawing in the background, and I've quickly created a Substation 1 line that's going to allow me to send that along with the configuration file to the Orion, make that configuration file active, and now I can view that on my local touchscreen. And if I want, I can go in, I can animate controls, I can apply tags, I can do everything that you can basically do with a full-blown SCADA. And I bet you we did that in less than 30 minutes.